Hey everybody, it's Mr. N here, and this is the 1-6 lesson from Big Ideas, and we're going to talk about pairs of angles today. So let's take a look at what we have here. Let's just go over some definitions that you already know, but are important to what we're doing today. So the first one is congruent angles. Angles that have the same measure are congruent angles, so they would be equal. Complementary angles, two angles whose sum adds up to be 90. So the key to complementary angles is the sum has to be 90. They don't have to be adjacent angles. And then supplementary, again, 2, but this time is 180. And they don't have to be adjacent. So here are a couple examples visually of complementary and supplementary angles. And take a look here. You will see that for these complementary angles, angle 1 and angle 2 add up to be 90. And again, here are two complementary, and these are not adjacent. Here's angle A, angle B, that's 20, that's 70. They add up to be 90. Angle 3 and 4 add up to be 180 because this is a straight angle. And then angle C and D, 115 plus 65, add up to be 180. So these are supplementary. Now, when I said the word adjacent, here's what I meant by adjacent. Adjacent angles are two angles that share a common vertex and a common side, but no common interior points. So if we take a look at this situation here, let me do a different color. We've got angle 5 right there and angle 6 as being adjacent because they share this common side and this common vertex, but no interior points. 7 and 8 do not share a common side, so these are non-adjacent. Now, we said for supplementary angles they did not have to be adjacent, but what if they were adjacent? Well, then we end up with something special called a linear pair. That's kind of like a straight angle. They form a straight angle, basically. So over here in this example, if I look at angle 1 and angle 2, right, these two are supplementary because they form this straight angle, but they're both adjacent because they have this common vertex right here and this common side. So angles 1 and 2 are adjacent and supplementary, so we're going to use this word linear pair instead. So basically, whenever you draw the straight line, and then you can make these angles, say 3 and 4 in here, or actually we'll just call it 5 and 6, right? Now these are going to be a linear pair because they form this straight angle and they are adjacent. And looking into our example here, 1 and 3 form a linear pair. 1 and 2 form a linear pair. 2 and 4 form a linear pair. And then 3 and 4 also form a linear pair because in this case, for 2 and 4, here's the straight angle, and these are the two angles right in here that I'm talking about that form that linear pair. All right, let's move on to the next page. It's a rather quick lesson today, and then we're going to do a few examples. So vertical angles are two angles such that the sides of one angle are opposite raised to the sides of the other angle. So in other words, think of it as whenever you have like an X, because it has to go all the way through. Oops, let's use a different one here. Whenever you have like an X, and if I label these, but just to note, your X doesn't have to look like this. It could look like this, right? Because that's kind of the same thing as an X. But the key is you need to have a straight line this way and a straight line this way that intersect. And I'll just go ahead and label these like I did above, 1, 2, 3, and 4. So we can say 1 and 4 right here are vertical angles because they are on opposite sides right there. The other vertical angles would be 2 and 3. Those are the vertical angles because they're on opposite sides of each other. So angle 1 and 4 are vertical angles, angle 2 and angle 3 are vertical angles in this drawing. And vertical angles are congruent, and we can go through and kind of do our first geometric proof as to why this is so. So let's take a look at why we know that vertical angles are congruent. So I'm going to go ahead and redraw this, what I have here. I'm going to go ahead and label this 1, 2, 3, and 4. And why do you think 1 and 4 would be congruent? Why do you think 2 and 3 would be congruent? Well, think about it. If you have this straight line, angle 1, and I'll write it right here, the measure of angle 1 plus the measure of angle 2 would equal 180. And over here, you could say the measure of angle 2 plus the measure of angle 4 equals 180, right? So look, I can kind of mathematically say, okay, since they both equal 180, I can put them equal to each other. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 4. But these two right here are the same ones. So I can remove those and look at what I'm left with. The measure of angle 1 equals the measure of angle 4. So we've just proved that they're congruent. So angle 1 would be congruent to angle 4. And we just went ahead and mathematically proved that this is correct. So here's your first geometric proof that we've talked about. And these are kind of the steps. We'll formalize this later when we do some more proofs, but that's just the basics of it. And you could do the same thing to prove that angle 2 would be congruent to angle 3. We are going to do these examples 1 through 9 in class, but right now I want to do some of these additional examples down here for you guys. For number 1, it says A and B are supplementary. Find the value of x, the measure of angle A, and the measure of angle B, given that the measure of angle A is that, and the measure of angle B that. Okay, so they tell us that they're supplementary. So that means the measure of angle A plus the measure of angle B would equal 180. We know A is 3x. We know B is x plus 20 equals 180. So we end up with 4x equals 160. So x equals 40. So we've got x now. And now we can find the measure of angle A. So I plug it in. The measure of angle A would be, and I'm plugging it in right here. So 40 times 3, which would be 120. And the measure of angle B would be 60. So these are the three answers that they asked for. Okay, for the next one, it says C and D are supplementary. Find the Y, measure of angle C, measure of angle D, given that. Okay, so it's pretty much the same type of problem, but this time they say they're complementary. So we know that measure of angle C plus the measure of angle D has to equal 90. So over here we could say 3y plus 5 plus the 2y plus 10 equals 90. And going through, we're going to say 5y plus 15 equals the 90. So 5y equals 75. Y will be 15. Okay, now I can plug this back in to get the measure of angle C. So since y is 15, 15 times 3 is 45, plus 5 would be 50. So the measure of angle C equals 50, and that means the measure of angle D should be 40, but you could verify it. 15 times 2 is 30, plus the 10 is 40. And those are my three answers there. Let's take a look at the next set of problems. We're going to do all these just so you guys know how to do these. Over here, find the value of x. So we've got 2x minus 5 equals 35. 2x equals 40. X is 20. For the next one, we have 2x plus 5. Now over here I set these equal because they are vertical angles, and that's what I'm doing over here too. These are vertical angles, so I could set them equal to each other. Equals 4x minus 35. 2x equals 40. X equals 20 again. All right, let's look at the next one. Okay, so I got a few things going on. I've got a right angle here, so that I know that that's 90. I've got x here and 35 here. Well, what I can do is this is a straight angle, so they all add up to be, so the 35 plus the 90 plus the x add up to be 180. So then I end up with 125 plus x equals 180. So x is going to be 55. On the next one, over here, I'm going to zoom in a little bit. So looking at this, we have, let me change the color here as well. We have these angles, and this is 3x, this whole thing. So that whole thing is made up of this one and this one together if I take a look at it. So this is this vertical angle. These are the vertical angles to each other. So 3x equals the 65 plus the 40. So 3x equals 105. So x will be 35. All right, let's slide this up and take a look at what we have here. I'm going to reduce this down a little bit. Okay, it says in the diagram, ray OC bisects BOD. BOD is 90, so that's this one right here that they're referring to. This is 90, BOD. And BOA is 40. And then we are told that it bisects this. So since it bisects it, so OC, that means this is 45, that's 45. So we can go through and pretty much solve for everything else that we need to, since let's go ahead and do that first, and then I'm going to answer the question. So sometimes it's easier just to go through and just put everything in here. Since this is 45, that'll be 45 because that's a vertical angle. That'll be 45 because that's a vertical angle. Over here, this is the vertical angle, so that's 40. And these two will be the same, which will be the leftovers. And what do I mean by the leftovers? I know that this whole thing all the way has to be 180. So 40 plus 45 and 45 is 90, plus you can call this your x, has to be 180. So over here, x will end up being 50. And that's because subtract 90 from each side, then subtract 40 from each side. So now we can answer the questions. B, O, C. I'm going to erase this thing, hold on, so that we can see it a little bit better. If I can find the eraser tool. And, okay. And BOC is right here, BOC. We know that that's 45. We had to answer that question by filling out everything. FOG, FOG is 45 degrees as well. And then AOE, AOE is 180 degrees. And then DOE, DOE was the x that we had solved for, so that's 50 degrees. All right, hopefully this lesson helped. Make sure you practice these. These aren't too bad if you make sure you understand what complementary, supplementary, and vertical angles are. So thanks for watching. Hit that subscribe button, and I'll see you guys in the next video.